Welcome back. This is an Aleks training video on predicting the relative strength of the dispersion force between molecules. All right, this is tricky. Actually, it's not terrible tricky. It's actually pretty simple. I think you'll get it. These all have no intermolecular forces except dispersion. Okay, what you're going to see is that all of them are have polar bonds, but they're not polar molecules. So let's look at yours for a second. So look at the shape. This is carbon tetrachloride, which is your third compound here on your homework, so CCl4. You've got carbon in the middle and chlorine on four sides, and they're all symmetric around the middle. Chlorine is more electronegative, so it's going to pull on the electrons more. Okay, so that means that's a polar bond. But all the polar bonds are canceled by everybody else because they're all pulling at the same amount, all in different directions, and so they cancel each other out. Every one of these are like that. Okay, so that means there's no polar, there's no dipole forces, there's no hydrogen bonding, there's nothing. The only thing that's attached, that's pulling on neighboring molecules are London forces or dispersion forces. Okay, so all of these are, and you have to rank them in boiling point. So if you can't use anything but dispersion forces, what are you going to do? Okay, well, if you think about what a dispersion force is, it's a momentary chance of one side having more negatives than the other. Okay, as electrons are whirring and whirring and whirring in a cloud around the nucleus, at any one moment, split second in time, you stop the clock, and wherever they happen to be, okay, is where they are. And at any one moment in time, you could possibly have more electrons on one side, less on the other. Okay, and that makes it just partially polar, where you have negative one side, positive on the other side, and there's a tug, electrical tug for that reason. Okay, so the more electrons you have, the more chances you're going to have of more electrons ending up on one side. Imagine if you had two electrons, the chances of them both ending on one side is lower than if you had 1,000 electrons. Okay, because just stop the clock and you have 60% on one side and 40% on the other, you've got a dipole. Okay, so that's what it is. You just want to look for the highest number of electrons. Now, I did the work for you this time. You're going to have to do it on your own. They're going to give you two compounds. You pick the higher boiling point. All right, so first one, silicon tetrafluoride, has 50 electrons in it because I just added up the atomic numbers of 4 fluorides and 1 silicon, and that adds up to 50. Silicon tetrachloride, since chlorine is bigger than fluorine, silicon tetrachloride is going to be bigger with 82 electrons. All right, so it will have the higher boiling point. Whatever is going to have the higher number of electrons will have the higher boiling points. Okay, so the first one will be this one. Okay, how about carbon tetrachloride and carbon tetrafluoride? Okay, carbon tetrachloride has 74, carbon tetrafluoride has 42, so 74 is bigger. Okay, so you're going to put one there. Lead tetrachloride has 150, germanium tetrachloride has 100. That's all there is to it. Just count your electrons.